Okay, let's solve this equation by use only Pythagoras. What Pythagoras theorem tells us? Pythagoras theorem tells us that a triangle that has a 90-degree corner, those are the legs, adjacent legs of the 90-degree corner, and this is called hypotenuse. Pythagoras theorem tells us that hypotenuse is equal to those adjacent legs squares, sum of squares taken square root. So now you can see how this is alike the expressions in our equation. So we are going to use that. If we can find a line like this, let's say this part is equal to this part of the equation, and this part is equal to this part of equation, then this AB, length of this AB will be our solution, right? Actually it will be minimum possible solution. So let's have this line. Let's first start with a line, and let's put a coordinate system here. This is point A and this is point B, and since we have x in our equation, we need a C point, and it should be on the y equal, this is x, we also can call this y equal 0 line, because this is y and y is 0 here, and so this line is y equals 0 line, right? And try to find the length from A to C. So first we will use a Pythagoras here. Let's say this is 90 degree. What could be the length, this length? So we're gonna use Pythagoras, and we are going to use this length. This is the hypotenuse of this triangle. So now let's highlight with red. We are going to solve this one, and this is, let's say we have here m for point A, this is x for m, so this is m, and n for y, so this is n, this is n. So this length is, since this is equal to x, right, this length is equal to x minus m, and this length is equal to n minus 0. So by using Pythagoras theorem we can find the length of this hypotenuse. Let's say this is, let's call it C1. So C1 is equal to x minus m square plus n square in square root. And let's say this is equal to our equation, it is this part of our equation. Let's say this is first part, let's say f1, so it's equal to f1, and it is x square minus 6x plus 13. So let's take the square of this parenthesis, it is x square minus 2xm plus m square plus n square. That will be equal to x square minus 6x plus 13. So x square here, x square at right hand side, x is taken as a multiplication minus 2m here, then it should be equal to minus 6. Then we know that m is equal to 3. And constant in this part is m square plus n square will be equal to, on the right hand side, plus 13. So m square plus n square equal 13. And the left hand side has a summation of two squares, and right hand side should be equal. Then what they should be? 3 square plus 2 square, right? That gives us 13. 9, 4, 13. M square plus n square. So m is 3 or n is 3. M equal to or n equal to. But we know here that m is 3. So we have no doubt that m will be equal to 3 and n will be equal to 2. So now we know that a takes x as 3 and n location as 2. Let's make a trick here and take the same length as this n here, and let's say this is a prime. So when this passes from C and reaches the B, this length, so this length which is equal to this f1 will be equal to that one, right? This is the first part of our equation. If we can assume that this part, which is CB, is equal to square root the second part, let's say f2, the second part, then this length, let's put one green, then this length will gonna give us this expression, right? And we will be solving our equation. So for this one we have again let's use this one. Now we are working with this triangle. Sorry, this triangle. So again, to solve this, I need to know this length and this length. So let's give P, let's say P and Q. Then here is P, right? And here is Q. So this length is Q minus 0, and this length is P, this length is P minus X. So apply the same thing like we did here. So P minus X square plus Q minus 0 square. We assume that this is equal to this part, equal to x square minus 14x plus 58. Then this will give us p square minus 2px plus x square plus q square should be equal to right hand side. No matter you are writing square roots or not, this is not really matter. So x square here is x square here. X takes minus 14 as a multiplication. Then here minus 2p. X takes minus 2p as multiplication. Then this should be equal to minus 14. Then p equal 7, right? And from here, left hand side, what is the constant? It is p square plus q square, and right hand side 58. Then those should be equal to each other. Then this is at left hand side again. There are two squares, summation of two squares. Then should be written 7 square 49 plus 3 square 9 is equal to 58. So which one is 7? No doubt, because we found P is 7, then P is 7 and Q is 3. Now we know that in B it is, we can write 7 3, right? So now let's use this orange color. So we were looking for A prime B. This length is now equal to our expression, right? Because we assume that this part is, we assume that this part is equal to this, which is this one, and this part is equal to second part of the expression, like here. So let's take this here. Now we achieved that what we were looking in the beginning. So let's call this A prime. This is 3 minus 2, right? Because this is 3 2 and this is A prime is 3 minus 2, and this B is 7 3. Again, just by using Pythagoras we can solve that, right? So what is the length of this leg? It is 7 minus 3. And what is the length of this? It is 3 minus 2, right? And from Pythagoras, let's say this is C2. Actually the C2 also is equal to our expression, right? It's equal to x squared minus 6x plus second part x squared 14x plus 58 is equal to 7 minus 3 square plus 3 minus 2 square root, and this will be equal to 41. And this is the solution of our equation.